Students, Prushti sir again discussing a very important topic for you. You must have come across this question in very often in JEE mains, NEET, etc. examinations. The question is, a capacitor which is charged is connected connected across a second capacitor which may be charged or may not be charged. Then they ask normally what is the heat developed and what is the common potential, like this they ask. Okay. So this we can do, no problem. But I give an easy method with a mechanical one-to-one correspondence. With whom? With what mechanics? The collision of two bodies. With that, how one-to-one correspondence I can make. So I'll make a one-to-one correspondence with a mechanical system in which there is a completely inelastic head-on collision between two masses without any external impulse. Without external impulse means why I am writing this? So that momentum you can conserve. Okay, mechanical impulse if it is not there, external impulse if it is not there, then you can conserve the momentum. That means collision between completely inelastic, in a plastic collision between two masses in a head-on manner. So, and I told there is no external impulse during the collision, so momentum remains conserved. With that, I am going to correlate with this charging of capacitor by another capacitor. Let us see this. So here, for the capacitor C1 is mass M1 mechanical system, C2 mass M2. Initial potential difference across capacitor C1 is V1. Initial velocity of M1 is small v1. Initial potential for capacitor C2, it may be charged, may not be orbital, call it V, capital V2. Initial velocity of mass M2 is small v2. So after collision, so what will happen after collision? Final common potential and final common velocity, call it Vc, small vc, final common velocity, and call the final common potential difference across both the capacitors capital Vc. Okay. Now consider three cases. What are the three cases? Based on the second capacitor. Second capacitor may be uncharged or may be charged. If it is charged, the connection between plus to plus plate or plus to minus plate. Let us see this one after other. Case 1. Initially C1 is charged to a potential difference V1. C2 is uncharged. Here I am showing the C1 is charged, C2 is uncharged. Initially, the mechanical system correspondingly, M1 moves with a velocity V1, M2 is stationary, V2 is 0. Just you can see here. There is no velocity. Let me write it as V2 0. This is V1. Okay. Right. So finally, I connect them. This is 0, 0 charge. So no charge here. 0 here, 0 here. So if I connect it, charges redistribute to some plus here, minus here, minus. Now it is connected. Common potential is Vc. Now we know from momentum conservation M1 V1 plus M2 into 0 is equal to M1 plus M2 Vc. So Vc is this. M1 by M1 plus M2 into V1. Okay. That's it. And here Vc is what? By same. M1 is C1. As I told you, M1 C1 by C1 plus C2 into capital V1. That is potential difference is V common. This corresponding to the mechanical system. What is the energy loss into heat form? As you know all, in a head-on collision between in a completely inelastic collision head-on between two masses. See what is the energy loss into irrecoverable form, that is predominantly heat form. Half mu into v relative square. V relative is initial relative velocity between the two particles. It's a completely inelastic collision. U loss. Okay, that's what I wrote here in the beginning itself. Charged, we can consider it to be the completely inelastic collision. This is a completely inelastic head-on collision. Should I make it a red mark here? Completely inelastic head-on collision. This is the, so in a completely inelastic head-on collision, what I wrote here, energy loss is half mu into v relative square. Relative velocity means velocity of relative velocity between m1 and m2 before collision, and after collision relative velocity is not there because they are sticking. They will be head-on perfectly inelastic collision. There is no relative velocity, but this is relative velocity before collision. So okay, how much it is in this case? V1 minus V2 magnitude will be V1 vector minus V2 vector. V2 is null vector, so V1 square. So this is what I wrote U loss. Similarly, U loss directly you can write here. Very simple. Since you know this, first know the mechanical system, then just rewrite the electrical system. C1 replacing M1, C2 replacing M2, then this velocity replaced by this potential difference replacing the V1. Initially only V1 there, V2 was 0. As you can see here, I wrote here also V2 0. Okay. Now initially C1 and C2 both are charged. The second case. Okay, they both are charged to a potential difference V1 and V2 respectively. Here what is the corresponding? Let us see this first situation. Both are charged to V1, V2 respectively. Positive plates here, the positive plates of C1 is connected to positive plate of C2, and their negative plates also are connected with each other. When positive to positive, negative to negative. This situation in mechanical system, what it is? Initially M1 and M2 are moving with velocity V1, V2 in same direction and they collide. Same direction moving and colliding means you are connecting positive plate to positive plate, negative plate to negative plate. This is before, I have not yet connected. Now this is after I have connected. Okay. After connected, then V1, V2, they are no longer there, become V common. Similarly, after collision, there is no V1, V2, there is a common velocity Vc. So momentum conservation will apply. What you get? What you get? M1 V1 plus M2 V2, same direction is M1 plus M2 in the Vc. Okay. So we get Vc as this. M1 V1 plus M2 V2, M1 plus M2. Since V1 and V2 in same direction, so they will be simply added. So Vc is equal to M1 V1 plus M2 V2 by M1 plus M2. Is it okay? Is it okay? Same direction. Here, let us see. So here Vc was the common velocities M1 V1 plus M2 V2 by M1 plus M2, or M1 V1 plus M2 V2 by M1 plus M2 in magnitude also. But here also same thing as V common potential is C1 V1. This V is potential. C plus C2 V2 divided by C1 plus C2. That's it. What is the loss here? Again, I told you half mu V relative square. What is mu? Mu is M1 M2 by M1 plus M2. Okay. That is the mu is the reduced mass. Mu is the reduced mass M1 M2 by M1 plus M2. You may ask, how do you derive this? That we derive in the mechanics in the system of particle momentum conservation chapter. Okay. So here also, what is the U loss here? V relative how much? They move traveling same direction means what the relative velocity? V relative will be V1 minus V2 or V2 minus V1. Magnitude will be same. Either V1 minus V2 or V2 minus. That's why I put a difference symbol. This is the V relative square. Okay. Well, write V relative square is V1 difference of V2 square. That's it. You may say, actually they're colliding, V1 must be greater than V2. If I can put a minus sign, absolutely no issues. But this is general expression. Okay. So same 1-to-1 correspondence. M1 is C1, M2 is C2. Velocity V1 is potential V1, but velocity V2 is potential V2. Okay. Am I clear? थोड़ा बड़ा कर देता हूं उसको मैं. कलर ऐसा करके बड़ा करते हैं. Okay. Fine. This is the second case. Positive to positive, negative to negative. Now third case. Initially C1 and C2 are charged to a potential difference V1, V2 respectively. Then potential of, well, then the positive plate of C1 is connected to the negative plate of C2 and negative plate of C1 is connected to positive plate of C2. Here similarly, initially M1, M2 move in opposite direction. That's important. Here they are moving in opposite direction with velocities V1, V2 respectively. Okay. Then they collide completely inelastically. And then I join them with positive to negative plate, negative to positive plate. And then what happens? This is the initial situation. Positive, this C1, V1 potential difference, C2, V2 potential difference. Okay. So C2, V2 potential difference, but positive connected will be this initial, not yet connected. In finally they connect positive to positive and negative plate connected. So finally charge will be distributed, some plus here, some plus here, some minus here, some minus here. The charge will redistribute. That's what I have shown. Okay. For example, if they collide opposite direction, they may be moving either both of them to this or both of them to the left. So depending on whose momentum is greater. Similarly, once I connect here plus to minus and minus to plus, depending on which charge is flowing more to which plate, so both will be either positive this side or both will be negative this side. So it doesn't matter at all. So finally, I am assuming this is plus, this is plus, this is minus after connecting. So what is the VC? M1 V1 plus M2 V2, M1 plus M2 VC. Okay. This is the vector. But they are oppositely traveling. So M1 V1 minus M2 V2 is M1 plus M2 VC. So what is VC? M1 V1 minus M2 V2 by M1 plus M2. It can be either positive or negative depending whose momentum is greater. Okay. That's fine. So as for the electrical concern, VC will be C1 V1 minus C2 V2 by C1 plus C2. It can be either positive or negative depending whose CV value is greater. Okay. C value is charge value. So U, what is the U lost? Again same for mechanical system, half reduced mass into V relative square, half M1 M2 by M1 plus M2 into relative velocity will be V1 minus V2 vector difference square. Yes or no? But since they are opposite direction, vector value added up V1 plus V2 magnitude square. This is half. This is M1 M2 by M1 plus M2. This is the loss. Similar loss here what correspond to this half C1 C2 by C1 plus C2. V1 is capital V1, V2 is capital V2. Understood this? This is such a simple thing. If you remember this, loss as half mu v relative square, write that and immediately transfer to the electrical side. So you can do it very fast. And why I'm discussing this, this is a very commonly asked question. Almost every alternate year coming to every batch, every year some batch you will be getting this in JEE mains, and JEE and NEET also is a very common one. Actually, I have to put a note here. In the mechanical system, heat energy loss into heat form in a head-on inelastic collision is given by this: half reduced mass 1 minus E square U relative square. U is the before collision relative velocity. Relative velocity between m1 and m2 before collision is U relative. E is coefficient of restitution. Reduced mass is m1 m2 by m1 plus m2. Okay, so this is what is the U loss into heat form. It is irrecoverable from maybe some part of the sound and all this. So E is equal to 0 for a plastic collision, perfectly inelastic collision, completely inelastic collision. E is 0. That charging a capacitor corresponds to perfectly inelastic collision. So this E has been taken 0. So half mu into E square is the loss. Okay. Half mu into U relative square is the loss. That's what I have been used all the three cases. With all the three cases, it is a perfectly inelastic collision equivalence for mechanical, for the electrical system. Okay. So this is when positive to negative connected, that is same as they are moving opposite direction. Here this is when it is positive to positive connected, that means they are moving in same direction, but relative velocity becomes difference, v1 minus v2. They are moving in same direction, plus to minus, minus to plus, relative velocity added because they are in same direction. So they are in opposite direction, relative velocity added. Opposite plates connected means they are opposite polarity connected means they are traveling in opposite direction. This corresponds to this. Same polarity plates are connected means they are traveling in same direction. This is case 2. And there is the simplest one because second one is not moving at all. So second one uncharged means second mass is not moving. That's it. But U loss is always the same because it's a perfectly inelastic collision. Loss will be this. It's just inelastic collision, 1 minus E square term will be coming, but that is not coming in this capacitor charging. Capacitor charging is equivalent to perfectly inelastic collision. Perfectly inelastic collision. That's what. All of you clear? If you are having difficulty in understanding this energy loss in inelastic collision mechanics, then we will take some class, but that depends on your requirement. Well, I just gave that you can handle this question very quickly, maybe within 30 seconds, in case it is asked in exam, but it is very commonly asked in the exam. That's what. The case 1, 2, 3. Okay. तो 1 को भी ब्रैकेट में कर देते हैं प्लीज, सबको ब्रैकेट में रखिए, तो 1 को क्यों नहीं करते? Cases. Okay. All of you clear? So this may help you in the upcoming examinations. Be careful. I hope you have understood all that which we have discussed today. And this is a very useful topic for you. May not be very difficult one, but very useful topic for you. If you can answer this, you can answer. If you are confident of this, have understood this, you can answer this question in just below 30 seconds. I'm assuring you. Thank you all. Best of luck for examination. Have a nice day. Thank you.